Hello friends, today we are going to discuss an important concept which is also a continuation to the previous concept we learned, which is the equivalent resistance across the diagonal corners of cube. So here are a cube of resistors. We need to find the equivalent resistance across the diagonal corners of the cube, that is equivalent resistance across the terminals A and B, and we got the value of RAB as 5/6 R ohm. Now we are going to solve this question by another method, which is the method of symmetry. For that, we need to look to the circuit through the terminals across which we need to find the equivalent resistance across. So we need to find the equivalent resistance across the terminals A and B. So we have to look to the circuit through the terminals A and B. By looking to the circuit through the terminals A and B, we can find a line of symmetry, which is this. So this line of symmetry cuts the resistors 1, 2, 3, 4, 5 and 6 into half of their value. So these are the resistors being cut into half of their value by this line of symmetry. So this is the half circuit. We need to solve this half circuit to find the equivalent resistance across the diagonal corners of the cube. We will see about it. First, we need to solve this half circuit. Here we can see these two resistors are in parallel, and also here and here. So there are two equal resistors in parallel. For two equal resistors in parallel, the equivalent resistance becomes half of the resistance value. So half of the R by 2 is R by 4. Here we can see this R and R by 4 is in series, and also this branch and also this branch. For series resistors, the equivalent resistance can be added. So R plus R by 4 becomes 5R by 4. There are three resistors in parallel. First, we will solve these two parallel resistors. So there are two equal resistors in parallel. So equivalent resistance become half of the resistance value, which is 5R by 8. So here is 5R by 8 parallel 5R by 4. For that, we need to apply the formula product by sum. That is, first we need to take the product, that is 5R by 8 multiplied by 5R by 4, the whole divided by the sum 5R by 8 plus 5R by 4. We will get the equivalent resistance as 5R by 12. This is only for the half of the circuit. We need to get the equivalent resistance across the diagonal corners of the cube. To get the equivalent resistance across AB, which is RAB, we need to multiply the RAX value by 2. That is 2 multiplied by 5R by 12. We will get the equivalent resistance as 5R by 6 ohm, which we already got it. Now I am going to introduce you to another concept. Here we can see for resistors, the impedance is equal to the resistance value. For capacitors, the impedance is equal to 1 by j omega c. So here you have to remember only one thing. For resistors, impedance is directly proportional to the resistance value, and for capacitors, the impedance value is inversely proportional. So from these two equations, we can infer that whatever we are going to apply for resistors, we need to take the opposite of that to capacitors. So for cube of resistors, we got the equivalent resistance across the diagonal corners as 5R by 6 ohm. So for cube of capacitors, we should get the inverse of it, which is 6C by 5 farad, where C is the capacitance value. And also we need to keep it in mind that for resistors, if we take series, we have to take for capacitors parallel. If we take resistors parallel, we have to take capacitors the series equation. Now we will see about it. So here are a cube of capacitors. Now we are going to solve this circuit by the method of symmetry. So the line of symmetry cuts these 6 capacitors into double the value, because for resistors we took as half of the value. For capacitors, we have to take the inverse of it, which is double the capacitance value. Here we can see there are two 2C parallel capacitors in parallel. So here also there are two 2C capacitors in parallel, and also here. As we already discussed, for capacitors in parallel, we have to take the series equation of the resistors. For series resistors, we will add the equivalent resistance value. So for parallel capacitors, we need to add the capacitance value. So 2C plus 2C becomes 4C. Here we can see these two resistors is in series and also in these two branches. For series capacitors, we need to take the parallel equation of the resistors. For parallel equation of the resistors, which is product divided by sum. So 4 multiplied by 1 divided by 4 plus 1, which is 4 by 5C. As we can see, these three capacitors are in parallel. For parallel capacitors, we need to take the series equation of the resistors, which is add all the three capacitance value, which we can get as 3 times 4 by 5C. And we got the half circuit value as 12C by 5 farad. We need to get the equivalent capacitance across the diagonal corners of the cube. For resistors, for that we multiply the half circuit value by 2. So here for capacitors, we are going to divide the half circuit value by 2. By dividing the half circuit value, which is 12C by 5 by 2, we get the equivalent resistance across the cube of capacitors as 6C by 5 farad. If you like the video, please subscribe to my channel for more such videos. So now we are going to simulate the circuit in TINKERCAD. For that, we are going to connect the multimeter across the diagonal corners of the cube. Here I have used 1 kilo ohm resistors instead of 1 ohm resistor. As you can see, we got the value as 833 ohm. But we do have to get the value 0.833 ohm. But as I have used 1 kilo ohm resistors, it is fine. Because the actual value of 5 by 6 is 0.833 ohm.